You're listening to Eureka on Monocle Radio, brought to you by the team behind The Entrepreneurs, the show all about inspiring people, innovative companies, and fresh ideas in global business. I'm Tom Edwards. Jen Keane is the co-founder and CEO of Modern Synthesis, a biotech company focused on creating sustainable materials using microbes. It all started after Jen realised the environmental impact of traditional textiles while working in sportswear design. That experience inspired her to pursue a master's in material futures, where she began experimenting with bacteria to develop alternatives. Jen launched Modern Synthesis 4 years ago alongside her co-founder, Dr. Ben Reeve, and now the company has a team of biologists, chemists and designers all working on reinventing materials. And guess what? The fashion world is taking notice. Last year, Modern Synthesis partnered with Danish brand Ganni to reimagine its Boo handbag using their bacterial nanocellulose material, a strong, lightweight alternative that's not only biodegradable, but also produces a fraction of the greenhouse gases and uses less water compared to natural and synthetic leathers. So, how does it all work? And how do you navigate the perception challenges associated with using bacteria in fashion? Well, here is Jen with more on how the journey began.
I'm Jen Keane. I'm the co-founder and CEO of Modern Synthesis. We're a London-based biotech company looking to bring life or our understanding of biology and the living world around us to the new materials that we're creating and the systems that we're designing to create those materials. I actually am a material designer and developer by background. So I spent most of my career in the sportswear industry. I worked for Adidas for many years in Germany, helped set up their material design creative direction team. And I think it was the first time that we realized not only the potential of materials to drive brand value, but also the reality of the problem that today's materials are driving in terms of sustainability and impact overall. I think most people don't realize that most of the things that you're wearing on your body today are either from an animal-based product or basically plastic. And there haven't been any alternatives. There's starting to be some alternatives, but even the ones on the market today are still predominantly polyurethane or PVC, different types of synthetic-based chemicals that we're wearing on our bodies. So my journey began when I was working on a project called Parley for the Oceans. So ocean plastic turned into shoes, ultimately. And it was a great first step to highlight the issue. But we realized that we actually need to reinvent these materials altogether and stop creating more plastics. So I came to London, did my MA here at Central St. Martin's in material futures, and I grew a shoe, as one does, working with a very early version of our technology and a bacteria as well that produces these really interesting fibres. And that shoe got a lot of mileage, no pun intended, and showed the potential of these materials to not just displace more harmful ones like leathers or synthetics, but actually help us design and create in fundamentally new ways as well. And that was sort of the kickoff point for Modern Synthesis. So I was working with scientists from Imperial College who have been studying microbes as a way of producing materials in the future. And the idea behind this is that microbes like bacteria and fungi, we hear a lot about sort of mycelium and mushroom-based materials, are very efficient at producing materials. And they were nature's original microfactories, or circularity. It's kind of started there. And so when I was looking at these bacteria, I was impressed with the performance of the material that they were producing and the way that they made those materials. And so I was looking at how do we actually take that natural process and build that into the design process itself. They create these tiny fibers called bacterial nanocellulose, and that's the smallest, finest form of cellulose. If you think of materials like cotton or linen or wood, that's all cellulosic-based materials. But these tiny nano forms of that material is really strong. And so we thought, how do we actually use this natural strength and create a material that can displace, durable materials that we know like leathers or synthetics in a new way? And so we've actually learned how to rebuild those biofilms and actually design a fundamentally new class of textile that can offer the performance and the aesthetic benefits, but without all the harmful emissions and pollution that comes with the existing ones. My co-founder is a bioengineer, so he's definitely the technical mind behind our technologies. Him and the team in our lab in Balham in South London are working on not only the scalability, so designing these processes so that we can hit the price points of existing materials, but also, again, diving into the potential from a technological standpoint to, again, drive additional value and performance in these materials. While I work with the customers, I've spent my career in the fashion industry, and so I was ultimately the customer prior, and so have built strong relationships with the customers and the brands that we partner with. We really do see them as true partners because we can't do this on our own. We need to work with the existing brands and supply chain if we're going to drive the impact we want to. The industry is committed to changing its practices. That being said, it's an enormous industry. I think people don't realize the scale of materials that are produced. I'm talking in like the hundreds of millions of tons that we're producing every year. And so the ability to create materials that can go back into circulation, that we can break down either naturally in the environment or recycle infinitely, because most plastics cannot be recycled infinitely, is a real challenge, but an exciting opportunity for us to actually build a better system. Perception is one of the biggest challenges in the space. And it's funny because bacteria are everywhere. And I think you don't think about it in your daily life, but yogurt is full of bacteria. Beer are brewed with a type of yeast. And so it's already in the products that we use every day. But the public perception of these organisms has become sort of dirty and ick. But actually, they're really quite normal and support a lot of the sort of lifestyles that we have today. But I think with other technologies that are starting to come out, I think people are starting to really accept. Also, like in health and food, there's a lot of work around the microbiome. So I think as a culture, we're coming around. So we started with a shoe that I essentially grew in my kitchen. And that maybe wasn't the most scalable at the first instance. And so what we've done is we've taken that process and the learnings about this really cool material. We've broken it down into different process steps and looked at what industries we could tap into, both the food industry as well as the textiles industry. And the thing is, bacterial nanocellulose is already grown at enormous scales. You don't think about it, but it's actually in those beauty face masks, those hydrating masks. It's also in a food product called nata de coco. And so we can tap into this huge supply chain for that. And we've learned how to convert equipment that's used for synthetic, so polyurethane, like coating machines and whatnot, within our process so that we can actually take what's existing and transform these materials into something that is scalable. So at the end, we create a material that's like a textile, and very similar processing to how we make textiles today. We're really excited to showcase the material with fashion brand Ganni. End of last year, we made their iconic boo bag in our material, and that has generated a lot of excitement within the fashion space. So first looking at handbags and traditional leather goods as a displacement for both leather and synthetics there. We're also working on footwear. Stay tuned for some exciting work that's happening in that space. Longer term, there's a lot of potential to drive impact within the automotive sector. So things like dashboards, seats, and actually beyond that, sort of performance coating. So we're looking at the ability of these materials to have other functionality, whether that's in electronics. We've done some color changing materials. There's just really untapped the innovations that we can build in to these materials from the start, but creating materials that are fully circular, and actually we can build into these circular supply chains of the future. I mean, our aim is to get these materials out in the hands of customers as soon as possible, and so that, people are wearing these materials, and because that's what drives the impact, is us displacing all the more harmful materials that are there today. So in the next, 5 years, I imagine people to be, wearing these handbags around and the shoes that we create. But I also, again, we're getting a lot of inquiries from parallel industries, whether that's, packaging, electronics, of how the same technology could be applied across the wider plastics problem. And that's really exciting for us to explore as well. So really untapped. I'm excited to see where that goes.
That was Jen Keane, the co-founder and CEO of Modern Synthesis, and you can learn more about the brand by heading to modernsynthesis.com. And that's all for this episode of Eureka. We'll be back at the same time next week. The programme was produced by Laura Kramer, with audio editing by Jack Dewars. Listen again and find out more at monocle.com, or follow us and catch up with the archive via your preferred podcast platform. If you'd like to get in touch with the team, send Laura an email on lrk@monocle.com. I'm Tom Edwards. Goodbye and thanks for listening to Eureka.